Okay, to add two fractions, you need to have a common denominator. And in some cases, if the two fractions have small denominators, for instance, 5, 6, if you wanted to add to that, 3/10, in this case, the denominators are small enough, and it's easy enough to just look at the larger denominator and find the multiples of that number until you find one that the smaller denominator goes into. So what I'm saying is we look at the multiples of 10, the larger denominator, until we found one that 6 goes into. So for instance, 10 is a multiple of 10 because 10 times 1 is 10, but 6 does not go evenly into 10. 20 is another multiple of 10 because 2 times 10 is 20, but 6 doesn't go evenly into 20. 30 is a multiple of 10, 10 times 3, and it turns out that 6 actually does go into 30, so there we found our LCD, and we can rewrite these fractions both having, so that both have denominators of 30 by multiplying this first fraction by uh, 5 over 5, which is really the number 1, so I'm not changing the value of that first fraction, and then multiplying the second fraction by 3 over 3, and once again that's really just the number 1, so I'm not changing anything, and I get two new fractions with equivalent denominators, with the same denominator, 25 over 30 and 9 over 30, and then I could add those together to get 34 over 30, and I would have added those two fractions. But the key is getting that common denominator. That would be one method, finding the multiples of the larger number, so until you find one that the smaller number is that is divisible by the smaller number. Now, let's say we want to add fractions like I don't know, let's say uh, let's say 11/24, 11/24, and let's say 17/90th. Now, in this case, it's a little bit more complicated. Well, not more complicated, but the numbers are a little bit larger, so it's going to be not harder, but more tedious if we wanted to find the least common denominator here. So here's another method of finding the least common denominator that works in the same way as the other way works. The other way is a little bit more intuitive. This way will allow us to get it even for large numbers. So the first thing we want to do is we want to find the prime factorization of all of the numbers, all of the denominators. So the first one, the prime factorization of the number 24. Well, the prime factorization of 24 is 3, oops, not 3. There's no factor, well, there's a factor of 3 in 24, but it's the larger factor. So let me list it in order of smallest prime factor to largest prime factor. 2 to the third power, if I multiply that by 3, I get 24. The other denominator, 90. 90 is the other denominator. And I'm going to do the prime factorization of 90. Well, 2 is a prime factor of 90. And then I have 3 is also a prime factor of 90, 3 to the second power. There's a factor of 9 in 90. And then 5 is also a prime factor of 90. So if you do a factor tree or however you find prime factorizations to get the prime factorization of 24 and 90, these are the prime factorization. So now I'm going to find the least common multiple, which is also the least common denominator for these fractions. And this is how we're going to find the least common denominator. First, we're going to identify all the factors that I see for either factorization. For instance, I see here a factor of 2, so I'm going to write 2, and then I look in both factorizations, both prime factorizations, and I take the largest power of 2 that I see in either factorization. And over here I have the power of 2 being 1. There's an implied 1 there. And over here I have the power of 2 being 3. So I have 3 for the power of 2 over here and 1 for the power of 2 over here. So for the LCD, I'm going to use the larger one, which is 3. Then I'm going to multiply this by, well, let me see, the next factor I see in order is 3. They both also have a factor of 3. So I'm going to keep my factor of 3. And then I'm going to look at the powers of 3 that are in each factorization. Here I have 3 to the first power, once again. And over here I have 3 to the second power. So I have 3 to the first power, and I have 3 to the second power. And what I'm going to do is I'm going to take the largest power that I see for the factor of 3. Well, 2 is the largest out of 3 and 1. So I'm going to keep a factor of 2 here for that factor. And then the last factor I see here, I see factors of 2s and 3s, but I also see a factor of 5 over here. So I'm going to write in that factor of 5, and since the factor of 5 only appears in one of the factorizations, I'm going to take the power of that factor of 5, which is the first power. So the 5 is going to be raised to the first power. And here we have the factorization of, or sorry, we have the, yes, this is actually the prime factorization of our LCD. So if we multiply these numbers, we will have our LCD, and that number is 360. So the least common denominator here is 360. And that is the process of finding the least common denominator using prime factorization.